Hello everyone. In this session, let us familiarize mesh analysis. So what is mesh analysis? Mesh analysis is where we identify the meshes and we apply Kirchhoff's voltage law. So applying Kirchhoff's voltage law, we are going to write the voltage equation at all meshes and we are going to solve the voltage equation and we are thereby going to find the value of mesh currents. So let me quickly summarize mesh analysis by breaking down into the following steps. The first step is to identify the meshes. So first let us identify the meshes and let us assume mesh currents. Assuming mesh currents is of our own freedom, we could assign any direction for the mesh currents. There is no strict rules to be followed while assuming the mesh currents. If in the problem the mesh currents are given, then we are supposed to go by the direction which is mentioned in the problem. If not, we are free to take any direction for mesh current. It could be either clockwise or anti-clockwise. So we are free to assume our own mesh current if they are not given alone. Okay. So the next point is to assign polarity. So we are going to assign polarity for all passive elements. So talking about passive elements, we are going to assign polarity for all resistor, inductor, capacitor based on our assumed mesh currents. Based on the direction of mesh currents. And then split the page into two halves, representing one side to be plus to minus and the other side to be minus to plus, and these two are having an equal to sign in the middle, stating which we are going to apply KVL to every mesh and we are going to write such an equation. And then combine all equations and solve the equations. After solving the equation, this is the most important step. Read the problem statement and check if you have answered the problem statement. For any problem, any circuit which is given, you could follow blindly these steps and you will be in a position to arrive at the answer. So now let us solve one problem. So here in this problem, we are provided with a circuit and the statement says that we are supposed to find the value of current that is supplied by the 10 volt source. So I'm supposed to find the value of I 10 volt. Okay. So let me write, let I 10 volt be the current supplied by 10 volt. And now let me start with the problem. So here it is said we are supposed to go for mesh analysis to arrive at the solution, right? So first, let us check how many meshes we have. So altogether we have 3 meshes. So I write number of meshes is equal to 3. So now let me assume the mesh currents. So I am at the first step, I have identified the number of meshes. I say we have 3 meshes. So let me assume 3, okay, his currents. That is, so this is one mesh. So this is going to be the direction of current I1. Let I1 be the current that flows in mesh 1. And the next current, so let this be the other mesh. So let me name the current as I2. And then let the third mesh have a current I3. So now, based on the direction, so now I'm taking you to the next step. So first step, we have identified the number of meshes and we have assumed the mesh currents. So you could write let I1, I2, I3 be the mesh currents. And now I'm going to the next step where I have to assign polarity based on the direction of mesh current. So normally, remember this convention alone. Whenever a current enters an element, that end is assigned a positive sign and the end where current leaves is assigned a negative sign. So here the current enters positive, here current leaves it's negative. Again here, current enters positive, current leaves negative. So we are supposed to assign polarity for all passive elements. Voltage source is an active element and hence you don't assign polarity for that. Now over to the next mesh. So I start from here, current enters this point, so plus, minus, plus, minus, plus, minus. So now let me go to the final third mesh. So here current enters plus, current leaves minus. Voltage source, we are not going to give any polarity because that is an active element, plus, minus, plus, minus. So we have assigned the polarity. And now the next step is to apply KVL, right? So before you apply KVL, we are going to now split the page into 2 halves. So we are going to split it as plus to minus on one side and okay, so on one side you have plus to minus and on the other side you're going to have minus to plus. Okay, so I have split the page into 2 halves. So now let me apply KVL to mesh 1. So whenever you apply KVL to a mesh, remember as if you're going to take a walk along the path of a park. Okay, so let me start from one point, rotate along the mesh and come back to the starting point. As I travel, I'm going to write all the voltages that I see. So let me now show you. So here I'm taking a walk. So I just start my walk from here. So from here I start to walk. So okay, as I walk, I travel from plus to minus. So from plus to minus, I find a voltage of, so it is a 1 ohm resistor where I have 2 currents. One is current I1, other is current I2. So look at the signs. I1, here it is plus, whereas on the other side, I2 has a minus sign, which means these two currents are flowing in the opposite directions. So when I write here, I write it as I1 minus I2. And then I continue. And again here, So if you see here, when you continue your walk, you again travel from plus to minus. So along the side plus to minus, I write the voltage drop. It is 1 into, again I1. I3 is opposite to I1, and hence I write it as I1 minus I3. And then I come back. Here, now I travel from minus to plus. Okay, so I walk from minus to plus, and hence I just write along the side of minus to plus, I write 10. Okay, so equal to sign split the page into two halves. And then I continue to travel. Okay, so now beyond this point, if I go, I'm traveling from plus to minus, and the voltage drop that I find here is 1 into I1. Normally, students make a mistake of writing here 10 I1. It should not be written 10 I1 because this 10 volt directly points that it is a voltage value. So it is not right to write 10 into I1. What would be 10 into I1? 10 into I1. 10 is already volt. V into I is going to be power. So if you write 10 into I1, that is not a voltage, that is going to be a power. Okay, so you have one equation. Now simplifying this equation, you'll have equation number 1. So let me quickly simplify. It is going to be 3I1 minus I2 minus I3 is equal to 10. So this is equation number 1. Similarly, we could write equation number 2. So let me write equation 2 here. So according to equation 2, so as you could see here, this is going to be mesh 2. So we are going to apply KVL to mesh 2. So when you apply KVL to mesh 2, it is going to be, so the current is going to travel in this direction. So randomly, let me select one point. Okay, so let me select one point, and from this point, I'm going to travel. That is, I'm going to take a walk. So when I walk from minus to plus. So minus to plus. So I see 5 volt. And then if I continue my travel, so if I continue my travel, I travel again from minus to, I travel from plus to minus. So along the side plus to minus, I'm going to write the voltage drop. So it is 1 into the current here in this mesh is I2 plus. Then I continue. So here I travel from plus to minus. I travel from plus to minus. So I write the voltage drop here. But here in this 1 ohm resistor, 2 currents are flowing. So if you take a note here, these 2 currents are flowing in the opposite direction. So I write as I2 minus I3. I2 minus I3. And then I continue to walk again. I travel from plus to minus. And again, it could be seen here that across this 1 ohm resistor, I have 2 currents flowing. One is I2, the other is I1. So I1 is opposite to I2, and hence I write I2 minus I1. Okay, so simplify this equation. And then similarly, you could apply KVL for the third mesh. So applying KVL for the third mesh, let me quickly write the equation. So while you apply for the third mesh, it's going to be 1I3 from minus to, you're going to, let me start my travel from this point, So I travel from plus to minus, so 1 I3. I travel from minus to plus and I see 5 volt. And then I travel from plus to minus and the voltage drop here is due to two currents. So I write it as 1 into I3 minus I1 plus 1 into, so this resistor plus 1 into, again I3 and I2 are flowing in the opposite direction in this resistor. So I write it as I3 minus I2 is equal to 5. So altogether we have three equations. Solving these three equations either using your calculator, having it in equation mode, or by applying Cramer's rule, or by writing the three equations in form of a matrix, taking an inverse. Thereby you have several methods to solve the available equations, and solving those equations you could find the value of I1, I2 and I3. So solving, we get the value of I1, I2 and I3 as I1 is equal to 7.5 ampere, I2 is equal to 6.25 ampere, and I3 is equal to 6.25 ampere. So we have the value of mesh currents. So what did we see as the sixth step? The sixth step was to answer to the problem statement. So what is the problem statement? Find the current supplied by 10 volt. So what is the current that is supplied by 10 volt? From 10 volt, I have a current I1 coming out, right? Do you agree? So this is the current that is coming out of this 10 volt. So I write I 10 volt, the current that I'm supposed to find, I 10 volt is equal to I1, which is equal to 7.5 ampere. So I believe you are now familiar with mesh analysis applied to simple circuits, and practice more problems to be proficient enough. Thank you all.